Good morning, guys. This is going to be one of two videos of our last videos of the school year, multiplying radicals. We've already simplified radicals with and without variables. We've added radicals, subtract radicals. So the two other just simple operations that we're trying to cover here before you guys head off to geometry honors is multiplying radicals and dividing radicals. Today we're going to cover multiplying radicals. And there's really two things that we have to remember when we multiply radicals, okay? The first thing is you always multiply the outside with the outside, and you multiply the inside with the inside. Okay, so really the number out front, which is called the coefficient, so it's the coefficient times the coefficient, and the number inside, which is called the radicand, which would be the radicand times the radicand, okay? The second thing is that all answers have to be in simplified radical form. Okay, and those are the two things we're going to stick by as we start working our way through. So we notice here, okay, for number one, we have root 2 times root 2 times root 3 times root 5. Well, the coefficient in front of all these is the same. It's 1. So 1 times 1 times 1 times 1 would be 1. So we're not going to write that, just like we wouldn't if it was in front of a variable. But root 2 times root 2 is actually root 4. Root 4 times root 3 is root 12, and root 12 times root 5 is root 60. And then we have our list at the top of perfect squares. The greatest perfect square that goes into that would be 4. So we're thinking of that as 4 times 15. So our final answer here is 2 root 15. Okay, that's the idea there. Okay, so if I go and multiply outside, I've got 1 times 5 times 2 is going to be on the outside. I have a 1 here, a 5 here, and a 2 here. So that would give me 10. 7 times 7 is 49. 49 times 10 is 490. And the greatest perfect square that goes into 490 is 49. So I'm going to pull out a 7. So I get 70 root 10. Okay. So that's the rule. 1 times 1 is 1. So I won't write that. But 15 times 10 is 150. Greatest perfect square that goes into 150 is 25. 25 goes in 6 times, so this becomes 5 root 6. Very important skill. This comes up a lot. We could see we can continue here with these. What we're going to do down for time's sake, to save time for you guys, okay? 4, 5, and 6 we would do in class together. We're going to jump down to these down here because I think these are a little bit more interesting, okay? And they review some really important concepts that involve multiplying radicals, but also multiplying things we've done in the past. So what we're looking at here is a monomial times a binomial. A mono times a bi. And we know we're going to distribute the root 10 to both of these. So what do we end up getting is 8 root 50 plus 7 root 60. The greatest perfect square that goes into 50 is 25. So I'm going to pull out a 5. That gives me 40 root 2. Greatest perfect square that goes into 60 is 4. We did it up above. So I'm going to pull out a 2. So that's going to become 14 root 15. And since these radicals are not the same, I can't put them together. And that would be my final answer. All right, so these are just going through some really good stuff. Hopefully here you notice we have a binomial times a binomial, so we're going to use FOIL here. Okay, I've got my first two, 5 times 7 root 2. So 5 is just a number, it's a coefficient, so I multiply the 5 and the 7. So I get 35 root 2. There's no radical there, so it's just we bring the root 2 along with it. Then I go to the outside, so then I get minus 5 times negative root 3 would be negative 5 root 3. Now I go inside. I've got 7 root 4. Well, root 4 is the same as 2, and 7 times 2 is 14. And then I have my last 2, which would be negative root 6. Okay, and it looks like, yep, unfortunately, none of those we could put together. They're all different radicals. This one's not a radical, and that would be done. Okay, we'll see something interesting with 9. 9 looks like a binomial times a binomial, which it is. The binomials are the same, the signs are different, so I'm just going to use FLA. Okay, so I multiply the first 2 together, I get root 7 times root 7, which would be root 49. Root 49 is 7, and maybe you see a shortcut there, which is if you multiply 2 radicals and the radicands are the same, your answer is the radicand without the radical. All right, the outside and the inside would cancel, that's why we just have FL. And then a positive times a negative would be a negative root 5 times root 5, again using the shortcut, which is be 5. And 7 minus 5 is 2. So that's pretty cool. We got one more to go here, which is a binomial squared. If you remember the pattern would be the first squared. So 2 root 10 times 2 root 10. 2 root 10 times 2 root 10 is 4 root 100. I got the first times the second, which would be 22 root 10 times 2, which would be 44 root 10. And then the second squared, which is 121. Well, root 100 is the same as 10. 10 times 4 is 40. And now I can add some of this stuff together, these numbers. 40 and 121 would give us 161 plus 44 root 10. And that would be your final answer. All right, so hopefully that's helpful. You guys now can work through the worksheet. I'll include that as well, and we'll go from there. Hope you guys are doing all right. 2 more days or 3 more days. You guys got this. Let's go. All right, I'll see you guys tomorrow.